Good morning, and here is a question from a recent exam. There are two in-phase loudspeakers that are placed along a wall and are separated by a distance of 4 meters. They emit frequency of 514 hertz, and a person is standing away from the wall in front of one of the loudspeakers. What is the closest distance from the wall the person can stand and hear constructive and then destructive interference? All right, the idea here is to find the path difference between the waves on reaching C, which is BC minus AC. That's going to be the path difference. If that path difference is equal to one wavelength, you will get constructive interference or maximum. If that path difference is equal to a half a wavelength, you will get destructive interference or minimum. Now, from the geometry of this diagram, BC squared is equal to AB squared plus AC squared. And AB is 4, so AB squared is 16, and AC is labeled D. So when you take the square root, you get BC as root 16 plus D squared. Now for constructive interference or maximum, set BC minus AC equal to lambda. So that's our BC minus AC is D, so that's equal to lambda. And now trying to solve this, take D to the other side, becomes lambda plus D, and then square both sides. The square root vanishes on the left side, and on the right side you got to do lambda plus D, the whole squared. And when you do that, you're going to have three terms: lambda squared plus 2 times lambda D plus D squared. Now on the left side we have 16 plus D squared, so the D squareds cancel out. Rearrange the formula to calculate D. So that's what you get, and when you plug in the value of lambda, oh goodness, I've not found lambda, so first let's find lambda. Now lambda is found from the formula, velocity is f lambda, where f is the frequency which is given. So lambda is velocity by frequency. I'm assuming the velocity to be 350 meter per second, which will be given, and the frequency is 514, so you get 0.68 meter. Now that we have got lambda, we can substitute the value here, which gives 0.68 squared by 2 times 0.68. On calculation, that gives 11.42 meter. All right, so that's how we do constructive interference. Now the same thing for destructive, except that the condition now is BC minus AC is lambda by 2. Why so? Because you get destructive interference when a crest and a trough are superimposed. For constructive, the path difference is lambda because you have either a crest and a crest or a trough and a trough superimposed. So all right, so for minimum, you set the path difference equal to lambda by 2 and do the same steps as before, trying to separate D from the equation. Again, this term is to be whole squared, so you'll have 3 terms on the right side. First one is lambda squared by 4 because you got to square both, plus lambda D because the 2 cancels out, plus D squared. Again, cancel the D squareds, rearrange to get D as 16 minus lambda squared by 4, the whole divided by lambda. And that gives, when you plug in the numbers, that's 0.68 squared by 4 divided by 0.68, which gives 23.36 meters. So that's how we do this problem. So understand that for constructive interference, the path difference, for minimum constructive interference, the path difference should be lambda. And for minimum destructive interference, the path difference should be lambda by 2. Why so? Because for constructive interference, you have to have a crest and a crest, or a trough and a trough, and the distance is lambda from a crest to the crest or a trough to a trough. But for destructive interference, got to have a crest and a trough superimposed, which means a crest from one speaker falling on a trough from the other. And in this case, the distance is lambda by 2 from a crest to a trough. So I hope this makes sense. Thank you for listening. Thank you for understanding physics.